Good morning, students. Our today's topic in the topic of differentiation is tangents and normals in the subject of pure mathematics 1 in A levels. So we are going to discuss the concepts and ideas of tangents and normals today and doing some questions. So first, take some concepts of the tangents and normals. So tangent is a line. Tangent is a line which touches the curve at only one point. Okay, this is the definition of the tangent. Tangent is a line which touches the curve at only one point, whereas the normal is perpendicular. Line on tangent. So normal is a line which is perpendicular to the tangent. So the next concept for you students in this topic is the gradient. Of tangent at x is equal to k for gradient of tangent at x is equal to k is dy by dx at x is equal to k, and it will be represented by, because we know from the coordinate geometry's concept that gradient is represented by m. So because this is a gradient of tangent, so we will put a capital T in the bottom. So gradient of tangent is equal to dy by dx at x is equal to k. And another concept of the coordinate geometry is also there, that when two lines are perpendicular to each other, so look now, when two lines are perpendicular to each other, like here we are seeing that tangent and normal are perpendicular to each other. So the another concept in the coordinate geometry was there, that the product of their gradients are -1. So the concept was in coordinate geometry was, if the gradient of one line is given, the gradient of the other line which is perpendicular to it was the minus reciprocal of this one. So it means if the gradient of tangent is this, then the gradient of normal will be negative reciprocal of this one. So that will be -1 over mt. So these are the concepts which will be used in this topic. So first understand and learn these concepts, and after that we are going to solve some questions. So concentrate now. Here is a question, and the statement of the question is, find the equation of tangent and normal to the curve y is equal to x square at the point where x is equal to 2. So for making the equation of the line, actually there are three conditions, out of which any one of the conditions should be fulfilled for us to solve the equation. So first condition is, from the concepts of the coordinate geometry, we must have gradient and y-intercept. In this case, we can use y is equal to mx plus c equation. The second case is, in case we are having one point and the gradient. So with the help of these values, we will use y minus y1 into m into x minus x1 concept. And the third case in the coordinate geometry was, if we are having 2 points x1 y1 and x2 y2. So in this case we can use the concept y minus y1 into x2 minus x1 is equal to x minus x1 into y2 minus y1. So out of these three, at least one case should be applied. So look now, because the equation of the tangent and normal are required, so x point is given. So if we put this x value into the equation, we can get the value of the y. So like this, y is equal to x square. So y is equal to 2 square. So we are mentioning at this at x is equal to 2. So y will be equal to 4. So the point is 2, 4. So one point is obtained. So if we get the gradient of the curve, that will be much easier for you people to write the equation. So this concept will be used then. So look now, we are going to find the gradient dy by dx of, so y's differential is dy by dx, and power will come down. Make one less from the power, it will become 1 now. So there is no need to write 1. And the variable which is having power is x, so differential of x is 1. So there is no need to write 1. So this is the differential. So now the gradient at x is equal to 2 will be called the gradient of the tangent. So 2 into, we are going to put x is equal to 2. So 2 into 2 will be 4. So this is the gradient of the tangent, and the gradient of the normal will be written as m base n, that will be equal to minus reciprocal of gradient of the tangent, that will be equal to minus 1 by 4. So we have find out the gradient of the tangent and normal at the one time. So that will be easy now to solve the equation. So there will not be need to find the gradient again and again. So look now, this is the point on the tangent. So using the point and gradient, so we are going to find the equation of tangent now. Equation of tangent formula will be used, y minus y1 is equal to m into x minus x1. So this is the point x1 y1, and this is the gradient of the tangent which will be put into this. So y minus 4 will be equal to, gradient is 4 into x minus x1 is 2. So solve it now, will be equal to 4x minus 8, and from here y will be equal to 4x. This 4 will go to the right side. So this is the equation of tangent. Now the equation of normal. Equation of normal. So look now, again this point is given and the gradient of normal is this one. So again the equation will be used, y minus y1 is equal to m into x minus x1. So we are going to put the values. So y minus y1 will be y minus 4 is equal to m. So gradient of the normal now. So gradient of the normal is minus 1 by 4 into x minus x1 is 2. So solving it further, minus 1 by 4x, minus minus plus 2 will be cancelled by this, so 1 by 2, and this minus 4 will go to the right side, so plus 4. So y is equal to minus 1 by 4 will remain as it is, and from here 8 plus 1 9 by 2. So this is the equation of the normal. Okay students, here is another question from this category. The statement is the equation of the curve is y is equal to 1 plus 1 over x. First part is show that the equation of the normal to the curve. So concentrate normal. So there are actually two things, tangent and normal. So in this part it is given that the equation of the normal to the curve at the point 1 2 is this one. So we have to prove this. This normal meets the curve again at B. Second part is find the coordinates of B. So look now. In this question, solution is actually one point is given. If we find the gradient of the curve at this point, that will be easy for you then to make the equation of the normal. So look now, gradient of the tangent. So first find the dy by dx. So dy by dx will be equal to, so look now, differential of the y is dy by dx. Here is a constant value, the constant value's differential is a 0, and plus this. So this will be equal to minus 1 over x square. So I'll show the method now. How? So look now, 1 over x is given, and first step will be this x will go in the numerator. So it means y is equal to this one. So find the differential of this thing. Power will come down. Make one less from the power and take the differential of the value which is having power, so into 1. So look now, minus 1 is there. This is minus 2. It will go back to the denominator. So this is the differential of 1 by x. So this is written here. Okay. Now we are going to take the gradient of the tangent. The point is here. X is 1, y is 2. So we are putting 1 in place of x. So this will be minus 1. And the gradient of the normal will be negative reciprocal of this one. So negative reciprocal will be 1. So moving further now, the equation of the normal. So because we have the normal now, so equation of the normal. Formula here will be used, y minus y1 is equal to m into x minus x1. This is the formula which is used. So here is the point, y minus y1, so y minus 2 is equal to gradient of the normal, that is 1, into x minus x1. x1 is 1. So opening the bracket, x minus 1 will be equal to this. In the next step, this minus 2 will go to the right side. So x plus 1. This is the equation of normal. So look now, which we have to prove this. So it is proved. Okay, second part is this normal meets the curve again at the point B. Find the coordinates of the B. So look now, here is the curve and here is the normal, that they are intersecting again. So the point of intersection will be, so definitely we are comparing. So here is the y's value of the normal and here is the y value of the curve. So we will compare these values. So it means 1 plus 1 over x will be equal to x plus 1. Okay, this plus 1 will come to the, or 1 over x is here. This x will come to the left side and this one will go to the right side. So on right side we have 0 now. Take the LCM of the left side. Here is x, so it will be 1 minus x square. Okay, this x will go to the left side, right side, so it will become 1 minus x square equal to 0. From here we can see x square minus 1 will be equal to 0. So x plus 1 into x minus 1 will be equal to 0. From here x will be equal to minus 1 or plus 1. So because the normal is meeting again, so it means a one point is here and the other point is the requirement. So we will ignore this point because this is point which is given. So we will take minus 1. So when x is equal to minus 1, so put this minus 1 anywhere into the curve or into the normal. So look, now we are putting this into this. So minus 1 plus 1 will be equal to 0. So y will be 0. So it means the meeting point, that is again B point, is that will be minus 1 and 0. So this is the other point. The question, students, the statement of the question is the curve y is equal to x square plus 2x minus 8. Cuts the x-axis at P and Q. Find the coordinates of P and Q. Okay, the first thing is P and Q is the requirement. So here is the solution. So you know, as at the x-axis y is equal to 0. So at x-axis y is equal to 0. So when we will put 0 in place of this one, so equation will be x square plus 2x minus 8. So first part, x square plus 2x minus 8 equal to 0. So this is a quadratic equation. So we will solve it by factorization or quadratic formula method. So easy is factorization method. So multiply the coefficient of the first one with the last one. So here is 8 and this, the coefficient of the singular variable is 2. Now think a pair of the numbers whose multiplication equal to this one, addition or subtraction equal to this one. So 4 and 2. Singular variable will be written with both of them. This sign is telling us that these values will have opposite signs, and this is telling us that greater will have positive and opposite will have negative. So we will put this factor in place of the central value. So it will become now x square plus 4x minus 2x minus 8 equal to 0. Make pairs take common. In the first pair, x is common, remainder is x plus 4. Minus 2 is common from the second pair, and the remainder is x minus x plus 4 equal to 0. The bracket which is same will be written once, so x plus 4 in the first bracket, and the values which are outside the bracket will be written in the second bracket. So x minus 2 equal to 0 as it is. From here the x values will be minus 4 or plus 2. Okay, when x is equal to minus 4, so when we will put minus 4 into the curve, so it will become y is equal to minus 4 square plus 2 into minus 4 and minus 8 as it is. So minus 4 square is 16. This will be minus 8 and this minus 8 is as it is. So it is minus 16 and plus 16 will be cancelled. So the point will be minus 4, 0. So call it one point, that is P. So P is minus 4, 0. Now use the second point, that is 2. So when x is equal to 2, now put this into this equation. So y is equal to 2 square plus 2 into 2 minus 8 as it is. So it will become 4 plus 4 minus 8. This is also 0. So the other point, that is Q, will be 0. Sorry, x point is 2, x coordinate is 2, and y is 0. So this is the point. Okay, 0. The reason for 0 is this, because the curve is cutting the x-axis. So y will be 0. So these are P and Q points. First part is done. The second part is find the equations of the tangents at P and Q. Okay, look now. Second part. Now we will differentiate the equation dy by dx. So dy by dx will be 2x plus 2. So gradient of one tangent will be dy by dx at x is equal to 2. Because here are 2 points, minus 4 and 2. So here is 2. So when this 2 will be put into this value, 2 into 2, 4, plus 2, 6. So this is the gradient of when 2 for point Q. Okay. So here is the gradient and point will be 2, 0. Likewise, we will find the gradient of the other tangent at the point at x is equal to minus 4. So here is the other point, that is minus 4. So when minus 4 will be put into it, it will become minus 8 plus 2, so minus 6. And minus 4 point was this one. So point is minus 4, 0. Okay, now we will use this and this to find the equation of the tangent. So equation of tangent at P. So at P point was actually minus 4. So this is the P point. So y minus y1. Y1 is 0 is equal to m. M is minus 6 into x minus x1. So minus minus will be plus. So plus 4. And from here y is equal to minus 6x minus 24. So this is equation at P. Now we are going to find the equation of the tangent at Q. So this is Q point and tangent was 2. So this was the condition. So these gradient and point will be used. So y minus y1. Y1 is 0 into m, that is 6, into x minus x1. So x minus 2. So y will be equal to 6x minus 12. So this is the equation of the tangent at Q. The third part is the two tangents meet at R. Find R. Okay. Third part. The two tangents meet at R. It means they intersect each other. So we will compare the values. So this is this y and this y's values will be compared. So minus 6x plus minus 6x minus 24 equal to 6x plus 12. This minus 6x will be shifted to right side. It will become 12x, and this 12 minus will come to the left side. It will become minus 36. 12 will come to the denominator, so x will be minus 3. So put this value of x in any one of the tangent. So for example, we are putting here. So y will be equal to, okay, come here now. So y is equal to 6 into x is minus 3. And this minus 12 will remain as it is. So minus 18 minus 12 will be minus 30. Okay, so it means minus 3 and minus 30 are the coordinates of R. Minus 3 and minus 30. So third part is done. The last part, find the acute angle between two tangents. Okay, another concept of the coordinate geometry will be used. So acute angle, fourth part. So tan theta equal to m1 minus m2 over 1 plus m1 m2 mod. So this was the formula in coordinate geometry for finding the acute angle between the two intersecting lines. So because tangents are intersecting each other, so look now, the gradients, here are the gradients of these two tangents. So now we are going to put the values into the formula. So suppose let this is m1, so 6 minus, this is m2 minus 6. So because of this minus sign, it will become plus. So okay, put minus 6 into the bracket over 1 plus m1 m2. So 1 plus 6 into minus 6. Mod is there. Actually, the function of the mod will be to make the answer positive. So this is the function of the mod. So moving further, 6 plus 6, 12 over 1 minus 36. Here is the tan theta that is moving in parallel. So from here we will solve it. So tan inverse, bracket start, 12 divided by, it will be minus 35, but mod will absorb it, so 35, bracket close. So the answer is 0.33. So theta is 0.33. Actually, my calculator is in radian mod, so first convert it into degree mod. So now tan inverse, bracket start, 12 divided by 35, bracket close. The answer is 18.92, almost 19 degree. So the answer is 19 degree answer.